Today in Precalculus, we were talking about fitting models to data and especially focusing on exponential and logarithmic functions. So far, we've worked with quadratics and linear models, as well as some other polynomials, but now we're just expanding that library. So if we're trying to fit data to a certain model, first, of course, we have a problem. So in this case, we're looking at one of the examples, example 3 in your book, which is on page 239. And our x values are minutes, our yield y has to do with a chemical reaction that occurs. And so what I'm going to do is make x, all my x's my list 1, all my y's my list 2. And so I'm going to come over here to my calculator. I already hit the stat button, so I'll just show you that again. You're going to hit stat, and that will take you right here. If I want to edit my list, I hit enter for edit my list. You can see I still have some data in here from when we were doing our practice in class. So I just hit clear and then enter, and then that basically clears everything out. So now I'm going to go ahead and put in my information, and on my table here I've basically got 1 through 8. So 1, 2, 3, 4, 6, 7, and 8. And then I go over to my list 2, and I've got this information here, which is 1.5, 7.4, 10.2, 13.4, 15.8, 16.3, 18.2, and 18.3. Okay, now that I'm done with that, I want to go ahead and look at my stat plot to kind of figure out what sort of model is going to fit. Now, there's two situations. You could be given a problem that says find a logarithmic function that fits the information, or you could be told find the best fit model. So I'm going to do this problem as if we were doing just find the best fit model. First, I'm going to clear this out because I have some information here, a line that I don't really want to look at. So I'm going to go ahead to my graph. You can see that this is zoomed in incorrectly. So to fix that, I'm going to go to zoom to the statistics. And there we go. So this is kind of, it definitely does not look linear in my opinion. And it doesn't really look exponential because I'd be seeing the curve going this way. So my guess is this is a logarithmic model, that I can find a logarithmic model that will fit this really well. Okay, so now I'm going to go back to my stat and I'm going to calculate. So what I want to calculate here is my natural log regression, or a log regression. We can also do an exponential regression, so I'll show you that would be this next one here. So I'm going to go to this, my natural log regression, and I'm calculating for list 1 and 2. I'm going to store it so that I can actually plot the model with the data itself, with the stat plot itself. And so I hit function y1 because that's where I want to store the information, and I'm going to calculate. And so I have in the form y equals a plus b natural log of x. So my a value is 1.538. We can round to 3 decimal places. B is 8.373. And my r squared value is 0.993. So that means that there's a strong correlation. And I can just verify that by going to my graph and seeing how that model fits the stat plot itself, and I can see it does fit very well.